Okay, another question from this March 17, variant 62. And it says now the length in centimeters of middle fingers of women in flower land have a normal distribution with mean mu and the standard deviation sigma. So this information I'll be writing this as X is normally distributed with this mean, and I have to mention the variance here. Okay, it says if it is found that 25% of these women have fingers longer than 8.8, so this means the uh, probability that X is longer than more than 8.8 cm is, I'll be writing this as 0.25. Okay, and the probability that shorter than 7.7, so this is X is less than 7.7, that is equal to 0.175. So that is how I'll be using, we will be using this percentage, changing this percentage into this probability notation here. Okay, so we have to find the values of sigma and this mu. So clearly there are two information fully, full information is given. So we can have two simultaneous equations here. So we shall go on to that standardization step here. So uh, this will be written as probability Z is more than this 8.8 minus mu over the standard deviation, that is equal to 0.25. So yeah, we're fine with this because there's a greater than sign and this probability is less than 0.5. So there's no need to think about, I mean, thinking of a negative value here. So this becomes 1 minus phi of 8.8 minus mu over the sigma, that is equal to 0.25. So this leads into phi of 8.8 minus mu over the sigma, and that is going to be 0.75. And this then becomes, now this becomes um, 8.8 minus mu over this, that is equal to phi inverse of 0.75. Let's see what is phi inverse of 0.75. So where is my table? Here is my table. 0.75. You see we have it here. If you look at the bottom of the table, so these are the critical values. You can quickly find the required Z values, the probabilities. So probability is 0.75. So this is going to be 0.674. Z is 0.674. 0.674. So I will be saying this is this 8.8 minus mu is 0.674 sigma. That is my equation number 1. Okay, then we um, have the second equation here, which is going to be, okay, the second equation is going to be from this information that we can simply say 8.8 minus mu over this sigma is phi. Oh, sorry, this is 7.7 here. Oh, sorry.
Sir, why are we using 0.677?
Yes, beta.
Sir, why aren't we using 0.677 for phi inverse of
0.677.
seven?
This is, look at this. This is 0.75. Look at the bottom of this. This is 0.75. And you have the Z value, which is 0.674. You can quickly use this value from here. Take this value from here, okay? Can you see this? 0.674 here? Yes? Do you get a different value from the table? Let me see that 0.75, 0.75. Where do we have 0.75? Yeah, here it is 0.75. So this is 0.67. It's the same beta. It's the same. Okay. So now this was to be 7.7 here. Like, we have to use this equation now. So this is 7.7 minus mu over sigma. That is going to be equal to 0.175. Now here's a problem, guys. That this um, this value over here, there was the less than sign. This is phi of this, and this is a probability which is less than zero point 0.5. Will not be able to find the phi inverse of this. Okay, so we have to make this value negative here. Okay, so let's write it phi of minus mu minus 7.7 over the sigma, and that is equal to 0.175. Okay, so now this would be 1 minus phi of this mu minus 7.7 over the sigma, that is equal to 0.175. So this is going to give us, this will give us phi of mu minus 7.7 over sigma, that is 1 minus this. So should that be 0.825? Hmm?
Yes, sir.
Yes, okay. So then we get this this mu minus 7.7 and over this sigma, that is phi inverse of 0.825. So this mu minus 7.7 is going to be, let's see what is this phi inverse of 0.825. Where is 0.82? This is 8212. So this is zero point 0.9. I'll be adding something into this. So this 0.92,
0.935, sir.
0.93.
0.934 नहीं होगा. Take the smaller value.
Just a minute. It was
Should we take the
point
smaller value or the larger
point
value?
eight two five. Just a minute. 0.825. 0.825. Okay. So I'll be using this 38 and I'll be adding 12, like this 13 into it. Hana? So this is 0.935. This is 0.935. 0.935. So this is 0.935 sigma. This is your second equation. So guys, once you solve these two equations, here is your first equation, okay? So you solve these two equations, you will be getting your mu and sigma. Unfortunately, I didn't manage this space efficiently. So now I have no space here to work out that. Let me do that on the side here, okay? Because I'm using a different kind of annotation today. So let me do it here. So if you people add these two equations together, you will see that this would become 88.8 minus mu, that is equal to 0.674 sigma. And I'm writing the other equation down here. This is plus mu, and I have minus 7.7, and that is equal to 0.935 sigma. So guys, when you add these two together, you have 1.1, and let's see what is the sum of these two. 0.674 plus 0.935. So this is going to be 1.609.
There is 1.609.
Yes, beta. This is sigma here. So your sigma is going to be 1.1 divided by this answer. So this is going to be 0.684. 0.684. So you put this anywhere here. So you get the other value around here. So this, I'm using the second equation. So mu is going to be 0.935 times this answer. You better write a, like, a longer value of this, and then um, this plus 7.7. So this is times 0.935, and then we have plus 7.7. So the mean is 8.34. So this is justified. This was a question of 5 marks. So there had to be so much working here. So whenever you, this was not enough space here to do all this working. So it is always handy to draw a vertical line, right? Like this, you draw a line here and you can double your space. Okay. Anyhow, so this is it from this part. I'll be doing the next one in the next segment.